Hello my dear friends, welcome to class 9 science. We are in chapter number 11, that is work and energy. Till now we seen what is work, difference in word work that we used in our everyday life and as we defined in science. After that we derived formula for work done, SI unit for work done, negative work, positive work, and few example, daily life example related to work. After that, we came to topic energy. In that, we have seen that energy is nothing but capability of doing work. Energy is capability of doing work. And we seen sources of energy, and we seen sun is the biggest natural source of energy. Other than sun, we have lots of other resources of energy, that is nuclear energy, thermal energy, tide energy, and many other source of energy. After that, we have seen SI unit of energy, that is same as SI unit of work, that is joule. We also seen that unit joule is smaller unit. In real life, we use kilojoule as larger unit of energy. Energy may have in different form. We discussed we have many forms of energy. For example, nuclear energy, kinetic energy, potential energy, heat energy, electrical energy, light energy, etc. Now, and we discussed demand of energy is increasing day by day. We have seen that small note on James Prescott Joule, who discovered this relation and verified experimentally law of conservation of energy, and also defined value of mechanical equivalent of heat. And in name of joule, we gave a unit of work and energy as joule. After that, we have topic that is kinetic energy. We discussed one activity 11.6. In that activity, we have one heavy ball. At certain height, we lift the ball and then release the ball on sand bed. By releasing the ball, we have depression on sand bed. We release the ball by certain height, say 25 centimeter, 50 centimeter, 1 meter, 1.5 meter, etc. And in that experiment, we notice that as height is increasing and we release ball from different height, say higher heights, we have larger depression in sand bed. What does it mean? It means that as we increase height of ball, it possesses larger energy in that. Due to this energy, we get depression in sand bed. After that, we have activity number 11.7. Let's see activity number 11.7. Set up the apparatus as shown in figure 11.5. So we have here figure 11.5. In that we have one trolley. This is the trolley. Here is one block. In this figure you can see this two block, but it is not actually two block, it is one block we will see in this activity what is the meaning of this two block. We have one trolley. This trolley is attached with thread or say string. This string is attached with one weight. Here you can see one weight. This trolley is attached through this pulley. This is pulley. And we know that as we increase load here, as we increase load here, weight here, mass here, as we increase mass, this trolley starts moving. And we have one block here. What will happen as and when we put mass in this mass attached to this string? This mass has some mass and it has weight due to its mass. So what will happen? This is trying to move in downward direction. So this mass move in downward direction. So this thread move in downward direction. Due to this downward force is transferred through this string to this trolley. And this trolley move horizontally on this table. This trolley move horizontally on this table. What will happen? Here we have one block and this trolley strike with this block. And here there is not drawn any stop, but here we have stop. That kind of stop that as and when this trolley strike to this block, this trolley will stop, and due to this strike, this block gets energy and it is displaced here. So here we have only one block, but in figure we can see two blocks, that is seen displacement of block. Initially the block is here, but as and when this trolley strike with this block will move to this another place, means it will displace. Now in experiment we will increase mass here or say weight here. Suppose initially we have 500 gram weight here, then we will put 1 kg mass here, then we will put 1.5 kg mass here. So what will happen? As we increase mass here, weight will increase. As we increase weight here, downward forces increase. Speed of this trolley will increase, and due to this, displacement of this block will increase. I hope you can understand. Suppose I have one object here. If I hit this object with lower velocity like this, what will happen? This object displays little bit. Now if I hit this object with larger velocity, what will happen? This object will move more distance. Similar thing is happening here. As here less weight are there will be less velocity. So the less force, so the less displacement of block. As we increase the mass, there will be more weight, so we have more velocity, so we have more energy, so we have more force, and more force, so we have more displacement of block here. So now I hope you can understand this situation. Now let's read activity. Place a wooden block of known mass in front of trolley as at a convenient fixed distance. Now we have wooden block. This wooden block, it is of known mass. What is known mass? Which means that if we place it, we know that this wooden block is of 1 kg, is of 2 kg, is of 3 kg. That is known mass. In front of trolley at convenient distance, place a known mass on the pan. we have pan here, we have pan here. In this pan, we put known mass 500 gram, 1 kg, 2 kg, 200 gram, 300 gram depending on weight of trolley. Place a known mass on the pan so that the trolley starts moving. That is obvious. Trolley starts moving due to this weight and downward motion of this pan. The trolley moves forward and hits the wooden block. What will happen? This trolley moves and hit to this wooden block. Now we have to fix one stop here. Here you can see there is a stop at the end, but here the stop like structure we have here also. So as and when the strike happened, this trolley will stop there at place and cannot move further. So fix stop on the table in such a manner that trolley stop after hitting the block. Trolley stops after hitting the block. The block gets displaced. So the block gets displaced. Note down the displacement of block. Note down the displacement. For example, block displaced by 20 centimeter, 30 centimeter, 1 meter. So we have to note displacement of block. How can we measure displacement of block? We measure initial position and final position. We have to mark fixed point on the block. Let's say we have it middle, we have our reference point. So mark here middle point and mark here. So we have 2 points on the table on which this middle point of block is lying. So we can measure the distance between this 2 point on table. So that is nothing but the displacement of block due to force applied by trolley. Note down the displacement of block. This means work is done on block by trolley as the block has gained energy. In previous lecture, we have seen that the object which exert force on another, normally both object exert force on another, but here we can say that trolley work on the block because trolley is in motion and it's tracked to block. So we can say that trolley work on block. So work is done on the block by trolley. Work is done on the block by trolley. By work done, the block gain energy and due to this energy, block can displace. From where does this energy come? From where does this energy come? This energy came from moving block or say moving trolley. The energy in block came from moving trolley. Repeat this activity by increasing the mass on the pen. As we discussed, we have to put different masses. We have to increase the mass 200 gram, 300 gram, 500 gram, 1 kg and repeat this process. What will happen? With increase in mass, we have increase in displacement of block. That is obvious. In which case is the work done more? As we increase mass, work done will be more. And at less mass, we have less work done. What is work done? Work done is nothing but displacement. Displacement by the force acted on block by trolley. In this activity, the moving trolley does work, hence it possesses energy. In this activity, moving trolley does work, on which work done on block. It can work because it has energy. Trolley can work because trolley has energy, and this energy is due to its motion, its velocity. So we can say that moving object can do work. Moving object can do work. An object moving faster can do more work than identical object moving relatively slow. Repeat. An object moving faster can do more work than an identical object moving relatively slow. Let's take one example. If we are standing on road and one bicycle or say one scooter came to us with speed 20 km per hour and hit with us. Okay, let's not hit with us, hits with some tree. There is one scooter moving with 20 km per hour speed and hit with one tree. What will happen? Damage, scooter will get damaged, person gets hurt. Okay, that is first situation. In second situation, same scooter, same person, same tree, but this time speed of scooter is 50 km per hour. Speed of scooter is 50 km per hour and scooter hits the tree. What will happen? Scooter will damage, person will hurt, but at this time damage is more, person will hurt more. Obvious. Why? Because at this time object moving faster, so it has more energy, so it has more work. So the identical object moving fast can do more work. I hope you can understand. A moving bullet, blowing wind, rotating wheel and a speeding stone can do work. Moving bullet can do work. It can kill people. Blowing wind. Blowing wind can do work. It can damage our houses, tree, etc. Rotating wheel. Rotating wheel can do work. On rotating wheel, if we attach a structure, our scooter, motorcycle, bicycle is a structure on rotating wheel, no? That is the structure on rotating wheel. So as wheel rotates, we can displace. Speeding stone can do work. How does a bullet pierce to target? How the bullet can insert or say pierce in target? Because it has velocity, it has speed. How does the wind move the blades of windmill? We know that windmill has its blade. This blade is moving due to wind or say velocity of wind. If velocity will below certain level, it will not move. In higher standard, in your standard 10, you will learn about windmill and wind farm. At that time, you will learn there is a minimum speed of wind is required, that is 15 km per hour to run windmill properly. So we can say that blowing wind can work, and by this work we can move blades of windmill and produce electricity. Objects in the motion possesses energy. We call this energy as kinetic energy. This is the definition. We can mark it and note it. Due to motion, object possesses energy, and this energy we called as kinetic energy. That is, the kinetic energy is energy due to motion of object. I hope you can get the point. what is motion or energy due to motion. Suppose this is my hand, this is stationary now, so it has energy but it cannot do work. But now if I move this hand like this, it can do work. It can do work. If there is a object in its path, what will happen? It will move it. It will move this object because now it has motion. So due to this motion, this hand possesses energy, and due to this energy, it can work. So I hope you can understand energy due to motion of the object, that is kinetic energy. A falling coconut, speeding car, rolling stone, flying aircraft, flowing water, blowing wind, running athlete, etc. possesses energy, and this energy is due to their motion, and this energy we called as kinetic energy. Falling coconut, speeding car, rolling stone, flying aircraft, flowing water, blowing wind, running athlete possesses kinetic energy. In short, kinetic energy is energy possessed by object due to its motion. We have another definition. Kinetic energy is the energy possessed by object due to its motion. The kinetic energy of object increases with speed. Kinetic energy of same object increases with speed. As speed increases, kinetic energy increases. How much energy is possessed by the moving body by virtue of its motion? Now we want to calculate the amount of energy possessed by the object due to its motion. By definition, we can say that kinetic energy of a body moving with certain velocity is equal to work done on it to make it acquire its velocity. Again, kinetic energy of body with a certain velocity is equal to work done on it to make it acquired that velocity. Let's understand this sentence. If I said 5 kg of mass, let's say 5 kg of wheel moving with velocity 5 meter per second. 5 kg of wheel moving with velocity 5 meter per second. Now if I want to know how much kinetic energy this wheel possesses, this wheel possesses energy that is equal to, suppose at initial level this wheel is at rest. From this resting position to this motion, I have to apply force. I have to apply force to get this wheel in motion. So the force that is necessary to gain this velocity or this motion, that is equal to kinetic energy. Again, if here is one object that is at rest, now I applied certain amount of force, let's say 10 Newton of force. I apply 10 Newton of force on this object. Now this object possesses energy. Object possess energy and do work or move. So this energy is equal to work done on this object. And what is work done? Work done is force into displacement. Force into displacement. So now I hope you can understand what is the meaning of kinetic energy, and by virtue of its motion we have kinetic energy. So in this lecture we have learned kinetic energy. We do two activities, activity number 11.6, 11.7. By this two activity we try to understand what is kinetic energy, how we can increase kinetic energy, on which kinetic energies depends. First of all, kinetic energy depend on velocity. As velocity will higher, kinetic energy will higher. And second is the mass. Larger the object, larger the mass, larger the weight, larger the kinetic energy. For example, if we have 1 kg of, if we have 100 gram of stone and another is 200 gram of stone. If I throw stone of 100 gram with velocity 4 meter per second to some object, object get displaced. Obviously object get displaced because I throw stone on that object. Now I throw same object, I throw object, another object, that is 200 gram stone with same velocity 4 meter per second. What will happen? The object on which I throw the stone will displace more, because now the stone get more energy. It has more energy because it has more mass. Remember, velocity in both the cases are same. Despite of velocity, mass is also dependent and responsible for kinetic energy. So we have seen that dependency of kinetic energy, and also discussed different, also mentioned different forms of energy. I hope you can understand it. I would like to say that if you want to score higher in science, understanding concept is not enough. Understanding concept is not enough. You have to read it many times, write it as many times as possible. Read it, write it, revise it, and try to write without seeing in textbook or any kind of material. Try to write in your own word, and don't forget that in definition you cannot change word. In definition you can't change word. If we ask definition in science, we have to write same word that is in our textbook. So in question answer, you can write your answer in your own words. But remember, there is a particular scientific words are there that should contain in your answer. Then and only then you can get better marks. So I hope you will remember all the information and understanding of concept and revise it thoroughly. Thank you.